Good evening, dear students. In the last class, we have discussed the basic concepts in the organic chemistry, that is chain length and word root. After that, we have also discussed some of the functional groups and different classes of organic compounds. See here, in the last class, we have discussed till halides. Till halides, we have discussed till the halides. We have seen what are alkenes, what are alkenes, what are alkynes, what are arenes, what are halides. Till here we have finished, we have discussed in the last class. Now we will go on to the next class of compounds. Before going to the next class of compounds, let us once revise what are alkanes, alkenes, alkynes, arenes, halides. Alkanes are nothing but single bonded compounds. They are also called the saturated organic compounds. They are having the general formula CnH2n plus 2. By substituting n value from 1, 2, 3, 4 and so on, you will be getting different members belonging to that particular class of compound, that is alkane. So the first member belonging to alkane is methane. The second one is ethane. Third one propane. Like that you can name the organic compounds. Similarly, when you come to alkenes, the first member will be ethene, because for a double bond you need two carbons. You need two carbons for a double bond. So it will start from eth. It means two carbons and you are having double bond. So ene. Double bond, we have to place the suffix as ene. It means two carbons and the suffix should be ene because it is coming under the category that is alkene. Similarly, alkynes. Alkynes are nothing but triple bonded compounds, and for this the first member will also contain minimum number of carbon atoms will be 2. So the first member in alkynes will be ethyne. After that propyne, and next butane, pentane, hexane, like that. And coming to arenes, arenes are nothing but benzene compounds. These are nothing but benzene compounds. Then halides. Halides are nothing but those are 17th group elements which are present in the periodic table. You should be thorough with the periodic table. You should learn group 1 elements, group 2 elements. Like that you have to be thorough in the periodic table. All the halogens and all the D block elements, F block elements and the inert gas elements which are present towards the right side of the periodic table. And then after halides, see here, after halides we are having alcohols. Alcohols are nothing but, here they have given you the functional group structure is OH. The functional group structure for alcohol is OH. That means this is a bond. This is a bond. After that bond you are having OH, oxygen and hydrogen. So OH group is also called as hydroxy group. Hydroxy group. Here you can see the prefix. Prefix is hydroxy and the suffix will be, for alcohols the suffix will be OL, all. OL, all. So while writing the IUPAC or IUPAC names, you should remember the prefixes and the suffixes for each class of organic compounds. For each class of organic compounds, these prefix and suffix are very important, as well as the functional group structures for each class of category are also very much important. See here, alcohols, you are having the functional group structure is OH. So beside this bond, substituents are present. So those substituents may be alkyl groups or phenyl groups. Alkyl or phenyl groups. I told you earlier in the previous class, I have told you what are alkyl groups and what are aryl groups, that is phenyl groups. See here, for alcohols, the general functional group structure is bond OH. They have given bond OH. Here you are having, these are substituents. This is nothing but alkyl. This is nothing but alkyl group. The general formula for this alkyl group is CnH2n plus 1. Okay, so if you substitute n is equal to 1, you will get this formula will become CH3. So you can name this organic compound as methyl. Meth, nothing but one carbon. Yl is nothing but, it is coming under alkyl. Group. So yl is nothing but the suffix which is added after the prefix meth. So here you can see number of carbon atoms, only one carbon atom is there. Okay, so meth plus yl, because it is coming under alkyl group. R is nothing but alkyl group. R is the general representation for the alkyl group. Similarly, in place of alkyl, you can also have pH or AR. pH is nothing but phenyl group. AR, aryl group. So these two are nothing but, the general formula for phenyl is C6H5. Here we are having one bond. You can see bond is there. So to this bond you can have alkyl groups or pH groups or aryl groups. Both are same. These both are same. So the formula for pH or aryl is nothing but C6H6. Aryl is nothing but C6H6. This is benzene. See, to this group, if any group is attached, the number of hydrogen will be decreased. Then it will become C6H5. This group is called as phenyl. After that, see, if alkyl group is attached to OH, this is called as alcohol. If pH group is attached to OH, hydroxy, this group is nothing but hydroxy group. This is called as phenol. This group is called as phenol. So alcohols, when alkyl group is attached, it is alcohol. When pH group is attached, it is phenol. After that we go to aldehydes. The functional group structure is CHO. Bond CHO. Aldehyde. See here I am taking aldehydes. The general functional group structure is bond CHO. So already, as I told you earlier, the groups may be R or pH. If the group is R, these compounds are termed as alicyclic. If the group is R, that is alkyl groups are attached to this functional structure, aldehyde, that will be considered as alicyclic compounds. If the group is pH, if pH is attached to this group, then the compounds will be termed as aromatic compounds. So for each category, here you can see aldehydes, the functional group structure is CHO. Towards the left side, alkyl group may be present or phenyl groups may be present. Alkyl groups are nothing but, as I told you earlier, this is the general formula. So I have mentioned the general formula. I have prepared the first member. This is the first member of alkyl group, that is methyl. Then the next member is ethyl, propyl, butyl, like that we go on. And then if you take the alkyl group, these alkyl groups may be CH3, methyl. This alkyl groups may be methyl or C2H5, ethyl, or C3H7, propyl, and so on. And what is phenyl? Phenyl is nothing but, I told you earlier, C6H5. So phenyl is nothing but phenyl, PH. Phenyl is nothing but C6H5 bond CHO. See, already for the aldehydes we have seen the functional group structure is CHO. So I told you it may be towards the left side, it may be alkyl group or phenyl group. If it is alkyl group, you can have these groups. If it is phenyl group, the group will be C6H5. Okay. So now in this aldehydes also, you can have two types of aldehydes. One is alicyclic aldehydes. The other one is aromatic aldehydes. Alicyclic is nothing but when there are alkyl groups in the formula. Aromatic aldehydes is nothing but when there is benzene ring. Benzene structures will be there, benzene. So benzene rings will be there in the compound. Such aldehydes are called as aromatic. You can see here different examples are also given. I'll solve each and every example. Now you see here, after alcohols, aldehydes I have finished. Aldehydes, so for each category till here all are acyclic or aliphatic, but from here all these compounds may be classified into alicyclic or aromatic compounds. So for alcohols, for each and every category you will have two types of categories. Alcohols, aliphatic alcohols or aromatic alcohols. Similarly, aliphatic aldehydes or aromatic aldehydes. Aliphatic are also alicyclic. We can have two names. So for ketones also, aliphatic or alicyclic ketones as well as aromatic ketones. Similarly, nitriles also. Here also you will be having alicyclic and aromatic. So for each category of the class of compounds, we have two categories. One is alicyclic or acyclic, and then aromatic. Then going to the next class of compound, that is ketone. Next class of compound is ketones. Now you see, I'll take ketone here. The general formula, see here, before going to ketone, here formyl or oxo is the prefix for aldehyde, and al, al. See here, note down the difference between alcohol and aldehyde. For alcohol the suffix will be ol, and for aldehyde the suffix will be al, all. And then coming to ketone, this is the functional group structure, and IUPAC group prefix is oxo. When ketone is there, ketone group is there, oxo is the prefix and on is the suffix. See, you will better understand when we go to the examples. When we solve the examples, you will be understanding further more. Now I'll take ketones. See here, ketones. This is the functional group structure of ketones. See, for oxygen, two lone pairs will be present. See here, how many bonds are there for carbon? 1, 2, 3, 4. 1, 2, 3, 4. See, if the bond is left like this, it indicates the presence of alkyl groups. If the bonds are left like this, it indicates the presence of alkyl groups. What are alkyl groups? Already I told you. It may be methyl, presence of alkyl groups. It may be methyl, ethyl, C3H7, that is propyl, C4H9, that is butyl, and so on. See, if the bonds are left like this without any group, it indicates the presence of alkyl groups. It indicates the presence of alkyl groups. Now, see, under ketones, here also we will be having two types: aliphatic ketones and aromatic ketones. Aliphatic ketones, aromatic ketones. That means in this structure you can have pH or you can have both alkyl groups, or you can have both aromatic groups. You can have one phenyl, one alkyl group. You can have both alkyl groups, or also you can have both phenyl groups. Next, we go to nitriles. Next one is nitriles. C triple bond N. See here, you can see the functional group structure is C triple bond N, and then prefix is cyno. Nitrile is the suffix name. Under this, they have mentioned they have given you the example. We will solve it after explaining all these functional groups. I will go to the example part. Okay, and then nitrile. Now you see nitrile. What is the functional group structure for nitrile? Nitriles. C triple bond N. C triple bond N. Here one bond is there. See here, C triple bond N. That means already I told you here the group may be alkyls or phenyls. Okay, so here also aromatic and aliphatic. C triple bond N. So these are called as nitriles. Nitriles are also called as cyanide. So you can see here nitriles, prefix is cyno and the suffix is nitrile. Cyno is the prefix which is used and nitrile is the suffix. Next, going to ethers. The next class of compound is ether. The functional group structure is ROR, and then prefix alkoxy is the prefix. Example is given. Okay, we will solve. Here you see two alkyl groups are present. Oxygen is present between two alkyl groups. Such compounds are called as ethers. See here, you can define ethers as when oxygen is present between two alkyl groups. Both should be the alkyl groups. Then only it will come under ether. Next, this ethers. See here, ethers, ROR. So, what is the general formula for ether? Now we go to ethers. Ethers R bond O bond R. Okay, so here these ethers may be symmetrical or unsymmetrical. Symmetrical or unsymmetrical. That means symmetrical ethers or unsymmetrical ethers. Symmetrical ethers are nothing but when both the alkyl groups are same. When both the alkyl groups are same, that will be considered as symmetrical. When both the alkyl groups are different, it will be considered as unsymmetrical. It will be considered as unsymmetrical ethers. That means I'll take example. I'll take one example. You can understand very well. Example. See, both for symmetrical ether, I'll take one example. CH3 bond O bond CH3, and this is symmetrical because both the alkyl groups are same. This will come under symmetrical. If you take another example for unsymmetrical, one is CH3 and the other one is C2H5. See, both the alkyl groups are different, so this will come under unsymmetrical. This is symmetrical. This is symmetrical. Okay, so here you can have different types, that is symmetrical ether and unsymmetrical ethers. Okay students, so in the next class we will discuss about the next remaining class of compounds, that is carboxylic acids, carboxylate ions, esters, acyl halides. Thank you dear students.